Thank you very much. Mustafa Demir, I am working at İzmir Institute of Technology. So we are sharing this time slot with Europe because in the last 10 minutes I want to measure a bit from everything we have done during this project. So this is outline. I want to just mention about geothermal mining since Katrin said me it will be public, open to public. So I want to say some general words. Then experimentation about lithium, strontium, and rubidium from Tuzla geothermal field. Then I will have an outlook. So on the right hand side you see the first powder we have obtained from Tuzla geothermal power plant.
No, go on this arrow, down arrow there, on the green button.
Yeah.
Yeah. And here make it smaller.
Aber,
No, it should be.
aber dann ist es doch. Wie kann ich es jetzt klein machen?
Normalerweise verschwindet das nicht.
Aber es verschwindet.
Wirklich?
Die Simona kannst du wegmachen. Da.
Die Simone kann ich wegmachen.
Okay, this is the powder of obtained from geothermal brine, lithium peroxide, one of the lithium compound. So the idea, as you all know in the room, the idea is to use this lithium obtained from geothermal field to use in a battery sector.
Click on the presentation box.
Okay, so this, yeah. So everyone knows we have conventional mining practices. There's a big hole in the earth, and this further increases the entropy of the world. And there are tedious 8 steps here to extract lithium. Another option could be evaporation ponds. In solar evaporation, we have evaporation left behind some solid mixture. This mixture should also be dissolved in water to make hydrometallurgy facilities to extract lithium or any critical raw materials. So we have geothermal brine here, as you see, you have seen solid settled down. So this is a clear solution, but it contains almost all cations in the periodic table. In the morning, Alkar mentioned that it includes even europium in the brine. It is very dilute, but it is ready for extraction, and we have to carry out hydrometallurgical processes. On the right-hand side, we see the last table made by European Union showing the critical raw materials. So there are 2 criteria: economically importance and supply risk. You see lithium is somewhere here, strontium is somewhere here. Okay, so these are 2 critical materials for Europe. So this is the picture of Tuzla Hill, beautiful hill. Behind this hill, there is small power plant, geothermal power plant that produces electricity around 7.5 megawatt electricity. So these are some general composition of the brine. Lithium is 24 ppm, sodium on the other hand 1,000 times richer, rubidium 10 ppm, and strontium 75 ppm. This is not. This is quite high concentration, ready for extraction. So this is the most west point of entire Asia continent. It's close to Asia Sea. So this is already mentioned in the previous talk. We are using manganese dioxide, and it is selective for lithium, not other similar cations like sodium and potassium. So this is the crystal structure of gamma type of manganese oxide. Lithium is loaded, and it is dissolved by using hydrochloric acid. But we have 5 steps: adsorption, desorption. We have to enrich the solution because it's so dilute. We have to purify. We have a target ion, but along with target ion, many others that we don't want. We have to get rid of them. Then we have to make a precipitation step. This is a yellowish green solution just because of the special complex between manganese and chloride. So we are using in-situ experiments into the geothermal field. We have a kind of stainless steel reactor, something like that, the size of 10 centimeter radius, 23 centimeters of long. And we have this porous medium, and we are using a textile material to keep this fine powder inside, and we are place this reactor into the reinjection valve after the energy is harvested. So we placed this reactor to do reinjection valve. We have a bypass line, and it worked quite nice. For several hours, we don't have any leakage from the system. We make absorption and desorption process at the same using the same reactor. So this is the powder I mentioned at the very beginning. If we dissolve in acidic medium and check the concentration by ICP-MS, you see it is quite lithium rich. We have sodium and calcium as well, and magnesium and potassium. But in total, we have more than 325 ion concentration. 250 is coming from lithium. In diffractogram, we observe, along with lithium peroxide, magnesium oxide reflections, but if we check the concentrations, magnesium oxide is very low, but it appears in diffractogram since it has very high crystallinity. So for strontium, we are using zeolite, clean optic type of zeolites. The concentration of zeolites in brine was 75 ppm. So it looks like an ion sieve. The concentration of all ions along with strontium increases. We get rid of these ions using ammonium acetate. Then we obtain very few amount of strontium sulfate. And you see the concentration of this solid material once dissolved in acidic medium. You see in total we have almost 600 ppm concentration. 400 is coming from strontium. It's not that much pure, but it gives some idea about our facility. So for rubidium, last case, rubidium concentration in brine is 10 ppm. We are using Bignesit type of manganese dioxide, but we are using a reaction to produce Bignesit type of manganese dioxide. This is a special sorbent for rubidium. Using synthetic brine, we have more or less 10 milligrams per gram sorption capacity. Increasing sorbent dose seems it reduced because it is normalized to amount of sorbent we are using. But if you see the removal efficiency, we almost recover 99% of rubidium in synthetic brine. For selectivity, along with rubidium, it catches some other ions, but rubidium sorption capacity is higher than those. For enriched solution, we make an enrichment to obtain rubidium-rich solution. In Tuzla brine, the initial concentration was 10 ppm. We increased to more or less 20 ppm. It is nothing. It is quite low, but there is room to increase the concentration of rubidium. This is not a conclusion, just outlook. I want to share some remarks with you. So, lithium and strontium source can be obtained from real geothermal brine. Economic feasibility, yes, it is on. It's a big question on the table. So rubidium can be enriched, but we are really far away from precipitation. The cost of sorbent is very critical because we are using sorption capacity, say 20 milligrams per gram or grams per kilogram. That means the amount of lithium carbonate or any target ion should be expensive than the sorbent you use to make it economically feasible. So there's room to increase this ratio. So the process should be continuous. We have to make absorption, desorption, and enrichment process at the same place. Now we are doing absorption and desorption at the same reactor, but we have to include the rest of the steps into this system. That's I want to thank you and thank my team. Seyra is working on lithium, Cem is working on strontium, and Özge is working for rubidium extraction. Thank you for your listening.